All right. Well, good afternoon, everybody, and thank you for joining us for our webinar, the Cloud Migration Playbook. We're glad to have you with us, and we'll get straight to it. Please allow me to introduce our cloud guru extraordinaire, Jason Sewell. Really quick overview. Jason's got 15 years of experience as a web application and systems developer, in addition to over 10 years in DevOps and systems architecture related roles. He began his journey into information security through necessity as he built skills and knowledge through his roles in leading internal initiatives for securing application and cloud infrastructure. Over and after years of blue team and developer or DevOps roles, his current interests center around offensive security and wanting to help organizations actively find problems rather than just following best practices and hoping for the best. The webinar is broken down into sections, so if you have a question as we go, please feel free to post it into the Q&A panel at the bottom right-hand side of the Zoom window. And of course, we'll have time for Q&A at the end as well. So without further ado, Jason, over to you.
All right. Thank you, Spencer, for that wonderful intro. So yeah, aloha and welcome everybody to today's webinar. And I hope everybody is doing well in their respective parts of the world. And for those of you working remote, happy 948th day of Groundhog's Day. Hopefully we can break up the monotony a little bit for you. So yeah, today's talk is titled The Cloud Migration Playbook. Part 1 is simple primer to complexity. And essentially what we're going to cover is just some high-level concepts for organizations that are considering a migration to the cloud and how you start looking at these things from a security perspective. So a little bit about me. Spencer already kind of gave a very good intro, but my name is Jason Sewell. I'm currently a senior security engineer here at OccamSec. You can find me on Twitter. As Spencer said, I started off as a web application developer. Actually started as a COBOL developer, kind of web enabling an old legacy system was my first job, but I've always been interested in the web and kind of that's always been my area of focus over the years. In that, kind of before DevOps was a word or a buzzword, we were managing a lot of our own application infrastructure out of necessity. And over the years, that's kind of, the new latest buzzword is DevSecOps, but really implementing more security, consideration, automation and modeling and stuff inside of that DevOps role. So currently working in InfoSec as a penetration tester, and I serve as the chapter lead here for OWASP Hawaii. And I do have some certifications. I've been doing AWS for about 10 years now, maybe a little bit longer. So I do have a SysOps and security certifications, and I've been building solutions in AWS for about 10 years. So in practice, I know what I'm doing, and I don't have a certification to back that up. But I've done a lot in AWS specifically. So more importantly, who are you, and who's this talk titled for? Ideally, for anybody that's watching this presentation today, you're a CISO, technical director, engineering manager, or just a security-minded advocate within your organization. But generally somebody that is, planning cloud migration, planning lift and shift kind of operations to the cloud, and just making sure that that you're doing so responsibly and aware of the environment that you're migrating to. So with that comes understanding the attack surface of just the cloud in general, but today specifically focusing on AWS resources and in general just validating that the proper security measures are in place as you migrate your processes and systems and applications infrastructure to the cloud. So with that being said, what do we want to accomplish today? What's our objective? So essentially, we don't want this to be you, right? you've seen all this stuff in the news. It comes up pretty frequently about how some aspect of the, quote unquote cloud has been breached, and an organization was found to be vulnerable. And a lot of these, big news ones have revolved around data breaches and involving lots of, large volumes of customer related information or internal IP, things like that. And so we want the important thing to notice is a lot of this stuff is preventable, and that's really what we want to cover. Is that if you kind of start to look at the attack surface and make sure you're modeling kind of that coverage area, that a lot of these things are like I said, preventable. And so we don't want this to be you. It's embarrassing. It's harmful for the organization. And so we want to talk about some of the common attacks and mitigation strategies as you move into this new environment. So with that being said, where do you start? Where's the beginning of this journey? Where do you start to focus your attention, efforts, and kind of comprehension of the cloud? And so what you see here, again, this is specific to AWS, but all of the large cloud providers really share this concept of shared security. And what that means is that the cloud provider is responsible for essentially for the data center. I mean, that's what it comes down to. And not only just one data center, but data centers all over the world, and different data centers in different regions. So they're managing, bare metal, racks and servers and network infrastructure, physical security at location, data center locations, and all this kind of stuff. So for anybody running their own data center prior to this, everyone knows that in of itself is a very large effort, takes a lot of people. It's a huge responsibility to get that right. And where your perimeter is. That's the thing, is that's kind of one of the things that changes. So that's what they take on as their responsibility, and they like to break it down into what's called the security of the cloud versus security in the cloud. And that's what they mean is that they will secure resources of the cloud, but then you as a tenant and a customer of their platform, your responsibility for what you put into their cloud. And so that is your customer data, things that we saw on the previous slide. That's your applications, managing your identity, which operating systems you choose to use, how you patch them, how you configure, network access and firewall configuration, yada, yada, yada. So that is your responsibility for deploying resources in the cloud. And that's kind of what that means. And for anybody that has been hesitant about making this move, we know that trust is hard. It's your business, it's your risk, all of those kind of things. And so that's a big step sometimes. So it's important to kind of understand where responsibility does lie. So the thing to remember though about this is as you kind of get into this, their part is pretty much done. They built an entire, business, and a massive business at that, off of doing their job and doing it fairly well for the most part. Your job is not done, and that's the hard part, and that's kind of what we're talking about. So having said that, is security actually shared in the cloud? And Gartner did a report on this recently, and one of the findings they had is through 2025, 99% of the cloud security failures will be the customer's fault. 99%. That's a huge number. And basically, what they're saying is it's not our fault. If anything goes wrong, it's your fault. And so, and that's a lot of pressure, right? So, so what's the main thing we have to worry about as we start looking at this environment? And for as simple as it sounds, the answer too often to these questions is misconfigurations. is that a lot of these things that you see in the news are not all that sophisticated. You know, the attacks are fairly simple, and it comes down to misconfigurations and things that were fairly easily preventable in the grand scheme of things. And that's easier said than done, you know. uh, but really, it's just where do you focus your efforts, and where do you make sure that training and comprehension is being dedicated. And so yeah, and kind of with that is to take that a step farther is a company called DiviCloud put out a report last year, and you know, kind of misconfigurations being this huge you know, failure often, is there's an entire report dedicated to just misconfigurations of the cloud, and a lot of research that's gone into that. And so as you can see, you know, recently misconfigurations have gone up by 80%, as did the cost of companies that got these configurations wrong. And that number is, you know, pretty highly correlated to the amount of adoption of the cloud, and organizations making that migration, and you know, and missing some holes in that process. But another interesting, you know, statistic to come out of that is relevant to specifically this talk is looking at cloud migrations as opposed to cloud native companies. Is that 68% of those companies that suffered a data breach were founded prior to 2010. And so what that means is that is companies that were not born in the cloud. A lot of their staff has been doing, you know, on-prem data center activities, and that's where their knowledge base is. You know, that's their domain, and that's what they know well. And so, you know, as these companies start to enter new territory, even if it's somewhat familiar, that's where some of the gaps can, you know, often occur. So kind of, you know, where, you know, again, we're kind of starting off with, okay, misconfigurations are a big deal. You know, how do we start preventing misconfigurations? And a lot of times it comes down to knowing your defaults. A lot of, you know, behind any product, there's a very good marketing department, especially companies that are successful at scale. And so, and also with, you know, with the nature of the cloud being web accessible, and any cloud service, is that a lot of organizations don't necessarily have control on when cloud resources started to be adopted. And so a lot of times for organizations, the cloud is already in use in some capacity before it's really gone through, you know, security review process and things like that. And defining, you know, training and mitigation strategies and all that kind of stuff. So so yeah, you know, to go back to the point about marketing, you know, to onboard customers easily to a new environment, they want to make it simple, right? You know, customer adoption is largely driven about, you know, how that initial experience of how easy it is to start using this product. And so a lot of the default configurations are more about onboarding experiences that are pleasant to the people using the, you know, the services, and not necessarily with, you know, security in mind, or complete security in mind, or contextual security of, you know, what different businesses might be doing with those resources. So and this applies to any technology, you know, and that's something I kind of want to point out as we go into this, is none of these concepts are new for the most part that we'll go over. It's just that they need to be reinforced as, you know, as you kind of, you know, get into new territory, like I said. And the deeper you get into the cloud, the more complex it becomes. And it goes way beyond the demos that you know, that people's content marketing teams are pointing out. So again, like I said, easier said than done, but you know, it's one of those golden rules. Like, always drive back to knowing what the defaults are, and identify, are they secure defaults or are they insecure defaults? It can really be as simple as that sometimes. So and we'll get to the meat of this in just a second, but a common you know, belief or a comment that you hear oftentimes is that when you're talking about the cloud, that it's just a buzzword, right? Yeah. It's still just servers. It's just, somebody else's servers, or we know this stuff already. It's just in a different, it's in a data center we don't have access to. And yes, that's all true. That's all correct. But kind of true, and there are nuances to the cloud. And um, so it's important to identify and respect kind of that idea that there is some differences, and really focus on what they are. So yeah, so we'll kind of, as we start this journey of kind of where do you begin, is that there's four key areas, regardless of how many services AWS rolls out. I think at this point there's like over 200. Don't quote me on that, but it is definitely in the hundreds. And so it's easy to kind of get ahead of it, of using the latest and greatest services, but really it still comes down to basic computing, right? So you have identity, you have data storage, you have networking, and you have compute resources. And so this is the areas where you should start your threat modeling and start to build security review processes around. So having said that, we'll start to look at each of these areas individually. And the first area that we will start with, and I was going to say arguably, but not really arguably, is identity. Is, again, kind of one of the buzzwords, catchphrases that you often hear nowadays, is that identity is the new perimeter. And it really is true, is that by nature of the way that cloud resources are deployed, and really the amount of risk and damage that can be done to an organization by identity compromise for an environment that is accessible on the public internet. It really is the new perimeter. If identity is compromised, it can be a massive failure for an organization, and very costly. When looking at, but it's hard. IAM is hard, and so IAM is AWS's specific kind of terminology for managing users and groups and permissions and roles and things like that. Is identity access management, if that's a new term. And so just in AWS alone, there's over 6,000 unique permissions across their platform, and it's growing every day. They every year re:Invent, they release X amount of new services, and they all come with new permissions. So it's real hard, and it's hard to manage and visualize the boundaries of these permissions. And so really, like I said, identity is where you should start, hands down. And so as we start to look at identity and kind of threat model around that area, what are some of the common attacks of, how attackers are going to try to gain access to identity, and then we'll talk about some of the defenses of how you can mitigate those attacks. So account takeover and credential theft are really, what any attacker is trying to accomplish when attacking a cloud environment. And account takeover can include, brute force, password spraying, credential stuffing, social engineering, things like that. Is that, again, to gain access to the web console on somebody's cloud environment is go to a login page that is accessible to the entire world and try to log in. And if you are successful with that, with an account that has elevated permissions, it's game over. They have access to everything to do anything that they want. And so, and another, related but different to logging into their web console is credential theft of programmatic access. So everything that you can do in the web console in all of the cloud providers, and again, AWS specifically, you can do via command line API and programmatic APIs. And so, with application managed infrastructure like that, you have access keys. And should those access keys be compromised, again, based on the level of access that's assigned to those, it can be catastrophic. And so this can lead to, this can be application breach. This could be malware on a developer's, laptop. It could be as simple as somebody committing API keys to a public repository. I mean, that's happened. It's happened many times, and you could go find instances of it right now. You go search on GitHub or public resources, and you'll find some. Okay, so those are the common attacks, but we want to kind of look at more practically, specific things that you should be watching out for. And this is the AWS IAM console, and this is real. Stuff that we've seen out in the wild is here on the left in the top left policy. You see, allow all actions on all resource, and what that is, that's God mode. That is saying you have the access to do or the ability to do anything that you want. And so, I want everybody to kind of, keep this phrase in mind. Like, I am not going to do this, and everybody that works for me is not going to do this. And kind of what you see here is, you see people that have left the company still, still having active accounts. You see new employees being kind of lumped into accounts with elevated access. You see MFA not enabled. You see, console, the ability to log into the web console for people that do not need to have that ability, and access keys that, that are potentially old or compromised. So again, these are areas of focus. And so how do you mitigate some of these, how do you mitigate this risk and prevent some of these attacks? And again, a lot of this stuff is basic. It's just new processes, and you have to make sure that you're ahead of them. So single sign-on and federation is available across all clouds, and there's many ways to do that. MFA enforcement, this is, at this point in 2021, it's common knowledge. Everybody should have MFA on everything. And it really mitigates, that one control mitigates so many of these attacks that we've seen, and mitigates the risk that goes with that. So if you're not using MFA right now, make that a priority. And outside of AWS, recently I was doing another, preparing some resources for Azure, and even putting up the steps together for how to turn on MFA. It's kind of ridiculous. So again, it's simple concepts, but in practice, it's just not that easy. Don't allow anybody to have API keys with root user access. Rotate user keys, have good role-based access controls, and least privilege. Like, again, when it's a new environment, when you're dealing with 6,000 controls and somebody's trying to deploy something on a deadline, and you have the ability to use wildcards to say, just make it work. Like, just make it work. This thing isn't working. I don't know why it's not working, because I'm not familiar with the environment, and I don't know which logs to go look at to tell me. So I'm just going to enable everything. So, no wildcards, no administrator access. And, I don't know if there's any, people working hands-on, but if there is on this call, I guarantee you or somebody you work with has administrator access. And so that needs to be kind of checked. And disable unused regions and services you're not using them. If you're not using them, then why should an attacker be able to use them? So, and it's easy for these things to go undetected. Okay. So moving on from identity, we'll start looking at data storage, right? Data is always the gold mine, the keys to the castle, and generally where risk lies within an organization. So we'll focus on just a key couple areas, some of the more popular services in AWS, but there's a lot more. So S3, data storage and databases and message queues, those are kind of the main ones here. And the reason they're the main ones is because they're all easily publicly accessible. And so So what do you see in these areas? You see bucket enumeration, data exfiltration attempts and successful attacks. Resource tampering and payload staging are some of the big ones that we've heard about recently. So, so what do those look like? Is bucket enumeration has really just been a big one over the years, and this is a site that if you haven't seen this, it's called Gray Hat Warfare. And really, what they do is they've just gone and crawled, publicly accessible buckets over the years, and through that, they've aggregated over 3.6 billion files, and this was a few months ago when we put this presentation together, for almost 300,000 open buckets. And some of these are public by intent. This isn't all a data breach. Some of these were designed to be public, but many of them are not. And it's as easy as going to a website and running a search, and that's kind of what we're talking about. Resource tampering. This is a real attack that happened to Twilio last year, and what the attack was is that they had a misconfiguration on a bucket that allowed anybody with any AWS account to upload files to a bucket. And so what an attacker was able to do was they were including JavaScript in a JavaScript file in their applications, and that's how Twilio gets integrated into other people's infrastructure and many other people's infrastructure. So what the actor did was he just overwrote the good file with a malicious bad file that had some extra code in it, and then that got served to all their customers. And it was really, again, not sophisticated attack. It was fairly easy to do. This is one of my favorite ones. I mean, this happened to Dow Jones, and what this is this most simple diagram you could put together for an attack is there was an Elasticsearch instance that was publicly accessible with no authentication, and somebody just accessed it and took 2.5 million records. And so and again, this is basic stuff. You have a database on the public internet with no credentials to access it. And one of the things I want to point out about this attack specifically is, in looking into this, it was a contractor that did this, right? And so that could be construed in a few ways. As it was deflecting blame. I mean, even in SolarWinds, right? They blamed it on the intern. The intern said about a password. It's the intern's fault, not us as a company. And that's I don't want people to buy too much into those assumptions. Is that, number one, contractors are used often, and just because someone's a contractor doesn't mean they should not have controls and be bound to your security process. Number one, and really, that most importantly, and also, it's not that contractors aren't capable. You need to make sure that your internal employees wouldn't make the same kind of mistake. So how do we mitigate some of these attacks and vulnerabilities? S3 specifically, again, this being an AWS talk, turn on block public access. They've made it a checkbox. That checkbox did not used to be there. And that's one of the other things. It's the last bullet point, but stay up to date on these things. Is that the cloud providers put controls in place as attacks happen over time. But if you're not always paying attention, you don't know that they're there. And so anything that was deployed years ago before these controls were in place could potentially still be vulnerable. But it's as easy as a checkbox, today. And then going back to IAM, bucket policies are kind of like the identity controls that you put around access to buckets. Tighten those down. Again, principle of least privilege. Only allow what by intent, what should have access to read, write, delete, all that stuff. For some of the data storage databases, don't allow public access. have controls to make sure that public access doesn't get turned on, and encrypt your snapshots. This is one of the things that I think is not common knowledge always, is that snapshots can be shared. And so if they're not encrypted and somebody actually has the right level of access of credentials that are compromised, they can actually transfer a data snapshot to a different account and kind of have access to that data. And again, that's basic. That's, you know, data at rest, right? I mean, that's not a new principle at all. Message queues. This is something you see often in kind of distributed systems. Is don't have public queues, and if you do have public queues, ensure again that your access is intentional. And you generally shouldn't have public read queues. Maybe you have public write queues. And again, encrypt the messages. It's not the default to encrypt them, so you need to turn it on, but it's easy to do. It's a checkbox. And again, IAM. You know, IAM touches every one of these areas. Okay. So next, we'll start to focus on compute. In AWS, these are virtual machines, these are virtual servers. They call them EC2, Elastic Compute Cloud. And again, you know, these are the same old servers, yes, except a little bit different. You know, it's different how you deploy them. It's different how you manage them. It is still a server, but it's in a new environment. It's not in your data center. It doesn't have your default perimeter just by activating it, you know, and it's easy to do. You can spin up a new server with the push of a button. So, you know, what are some of the ways that compute is vulnerable, and what people are looking for is, again, this is basic stuff. This has nothing to do with the cloud. It's just in the cloud, it has different, there's different post-exploitation methods primarily, but service enumeration, what's exposed to the internet, port scanning, you know, application exploits. If somebody can, you know, remotely run commands on a server, then they can turn that into post-exploitation. And pivot with access to credentials, perform lateral movement. You know, real popular thing lately has been cryptojacking and just installing miners and stealing resources, not necessarily data. And, you know, unencrypted volumes, unencrypted data. So, you know, again, the Shodan, if anybody's not familiar with that, public website, you go fill out a search bar and you get results. And if you could just go search for EC2, you know, there's 40,000 potential targets, 43,000. And this is kind of the stuff that you see, is that, you know, here's a server with many ports open, and should it have that many ports open? Probably not, right? And but that's attack surface, right? That's what, you know, attackers are looking for. Here, this is a diagram of the Capital One breach. Again, really famous breach. You know, the follow-on investigation for figuring out what happened was pretty extensive and kind of drawn out over time. But what happened was that an attacker was able to exploit an esource vulnerability on a publicly accessible virtual machine. And what they were able to do was get those access keys. So access keys are what that server has the permissions to do within that cloud environment. And so when somebody is able to get those keys, then that enables them to have access to anything that service has been configured to have access to. So what you see here is that Capital One had all of their their S3 buckets secured. They had them hard, and they did the right thing. They weren't using defaults, and that was a good thing. But what happened was, when somebody did get a single key from a single application, and Capital One, you know, massive infrastructure, right? They you know, they have a ton of stuff. That one key, based on loose controls, gave them access to over 700 S3 buckets. And in that, there was social security numbers, credit card numbers, all kinds of information, and by exploiting one application again, you know. And you know, so again, this goes back to IAM, is that one application does not need access to 700 buckets. And so this was a security misconfiguration. This was an identity misconfiguration, but chained together with an application vulnerability, with security misconfiguration, and it was catastrophic, right? Big news and big deal. And so yeah, so to mitigate that, if the application credentials had access to 2 buckets that the application needed, maybe it wouldn't have been that big of a deal. Okay, and this is a little bit, this is not a specific attack, for a specific company like I've shown in the other slides. This is what's possible, with post exploitation. Again, this generally comes down to, can someone get an access key? And if they can, these are all of the things that they can do, is that they can establish persistence through creating new identity roles. If the keys are going to get rotated, even if you have a good key rotation policy, if the keys that they compromise have excessive permissions, they can go create their own identities. And if you have, 700 users, even if you have 100 users in your IAM, are you going to notice one new one? They could access, data storage. They can perform lateral movement to other virtual machines and potentially get to data resources. And so, so there's a lot of, and this is kind of the stuff we talk about that's a little bit different. Like, yes, it's servers. Yes, it's the traditional stuff that you're used to, but everything behind those servers is service, basically SaaS, right? It's all service infrastructure. And so it's not necessarily pivoting in traditional sense. When you get those keys, you have access to a lot of APIs, and also the ability to, go machine to machine. But and then as people are setting up on-prem, to the cloud, potentially you have lateral movement between a cloud environment and an on-prem environment in those hybrid cases, or the other way. So hybrid infrastructure is something you need to, keep in mind as well. Okay, so how do we mitigate these? What are the defenses for these? And these are not new. Protect instance metadata is probably the only new concept on here, but just like any server, just like any server, follow your hardening best practices. Install a firewall. Just because you have a cloud-based firewall doesn't mean you shouldn't have a virtual machine firewall enabled also. Defense in depth, it's the same old stuff. Create user service or create user and service accounts on these machines. Again, convenience. When you roll out a virtual machine, you get a default user with sudo access, because how else are you going to give somebody access to a remote server that they don't have physical access to? You can't go plug into this thing. So a lot of times people use that default user, they deploy application infrastructure. And again, if you have an application vulnerability, that person automatically has sudo access, root access to that machine. And so, so again, when you're deploying servers, follow, common best practices that you're already doing. Have, use the services that are in place. You have load balancers, you have web application firewalls. They're actually pretty easy to set up. So take advantage of them. Don't put bare metal on the open internet. Put infrastructure in front of them to mitigate some of these stuff. Even like DDoS attacks, it's something that the cloud does very well, is that they can handle those kind of high volume attacks and not, and prevent, those distributed attacks and things like that. Encrypt your data at rest, again, yada, 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 same stuff. And then make sure people understand what instance metadata is and how to protect it. And again, it goes back to IAM. Don't give excessive permissions to a virtual machine. Okay. Last but not least, this is kind of the last vertical that we'll get into, and this is networking. Basic networking. And yes, again, same old network except different. And I say this from developer's perspective, even DevOps, I've never been a network engineer per se, but networking's hard. Like, it's hard anyways. And that networking and doing it in the cloud, again, when you don't have physical access and kind of doing the same things in a new environment, it's hard. It's hard, you know. And one of the other things that, to keep in mind in networking is that you have this, this concept of democratization in the cloud, is that you have people deploying network infrastructure that are not network engineers and do not have networking backgrounds. You have developers that are creating virtual networks with infrastructure as code and things like that. And that's not their domain. They understand it. They're smart people, but they're not well versed in all the ways to ensure that it's secure. So I'm going to go through this one kind of quickly, and we'll try to get to some questions. But what are attackers going to try to do? Service discovery, again, what are you allowing access to from the public internet? What is your fire? Do you have a bunch of holes in your firewall? Are you filtering traffic that to get access inside and outside? Are you restricting egress traffic just as much as ingress? How easy is it for somebody to perform lateral movement? Kind of like we talked about, if you're setting up a hybrid environment, can somebody move laterally from on-prem to the cloud, and vice versa from the cloud to on-prem? If people get access, again, with IAM credentials, they can set up backdoors by creating, policies that allow them to have persistence, at least at the network level. And again, this is software-driven configuration. It's hard to detect that somebody has done that. And nothing by default in the cloud is going to tell you that somebody's done that. And that's all that manual effort where they say it's shared, but it's a ton of work to actually, implement all of the controls on your side and get it right. And, traffic monitoring, if somebody can, get access internally, how much encrypted traffic, are you doing, do you have HTTPS encrypted connections between servers and within your infrastructure that's being deployed, things like that. So I don't have any diagrams for this because this is part of most of the attacks that I've gone over. But again, it just goes back to the basics. Network segmentation. Don't put all your eggs in one basket. Create strict security group and network ACL rules. Really, again, threat model your virtual network just as you do your physical one. The security group rule, the third bullet point, SG is security groups. And IP addresses change a lot in the cloud because you're leasing them. You don't own them like an on-premise, on-prem infrastructure. And so a lot of times when you're setting up firewall rules, we're used to doing them by IPs. But in the cloud, you can actually manage access by security groups, and you can lump, applications in security groups and subnets and things like that. So don't use IP addresses is really the key takeaway. And then this is another one that by default, people don't know this, but there's a concept. VPC is the virtual private cloud. That's the network environment, if you're not familiar with that term. And there's internal endpoints that if you want to talk to applications and service internal to the cloud, there's different endpoints that you talk to. And the default endpoints, if you're talking from an application to S3, those endpoints, they're secure, the HTTPS, but they actually go out over the public internet. And many people don't know that. That's not kind of common knowledge. So, if there's traffic that should never leave the perimeter, use that to your advantage. So yeah, and also get the right this is important, is get the right people involved in this job. Like I said, developers, if they're going to automate infrastructure as code, that's great, but make sure that they're working with security people and networking engineers, that they're covering all their bases by working with the personnel that know that domain well. So it's really important. Okay, So those are the 4 key areas that, you know, you know, when you go through it, it's not new per se, but it's just bringing light to where to focus if you're starting to go down this road. So, you know, how do you manage this? You know, migrate your practices, not just your applications. And that's, you know, again, it's one of those golden rules is if you're doing something on-prem and you're migrating that to the cloud, there's almost nothing that you can't do in the cloud, just like you're doing on-prem. And so if you have practices in place, then make sure that those same practices are applied to a new environment. There's all the tools are in place, and whether they're cloud native tools or, you know, third party vendor tool, or, you know, that you deploy in the cloud or plug into your cloud, there's really nothing that you can't do in that environment. But again, the fact of the matter is it's familiar concepts in a new environment. It's the same things that you do, but it's different ways that you do it. So really make sure that you're migrating everything and not just pieces. Automation. With the expanse of services and the fact that everything is events and APIs and things like that, and deployment, and again, not having the security blanket of a physical perimeter, to know that somebody is not deploying resources in your data center, you really have to automate everything, and just dedicate to that process. So, you know, use it to your advantage. Again, all the tools are there. So if you don't currently have like a DevOps, DevSecOps team, and security engineering roles or application security, you know, roles, build a team if it doesn't exist yet, or if you don't have that team, at least find a champion in these key areas that are going to, you know, go deep and really take on this new environment, and make sure that those roles are in place. You have infrastructure as code. You know, Terraform is kind of the big one, but you know, don't let people be in the habit, or don't get in the habit of using the web console to manage your infrastructure. It will fail. It's, you know, it's not productive, number one, and number two, it's almost impossible to get right over time. Especially if too many people have access to the web console. People just go do stuff, you know, and if there's no change management policy in place, then it just gets real hard to manage. Monitor events. Again, there's just a million events happening in the cloud. And so and this is probably one of the hardest parts, I think, is you don't even know what you're supposed to monitor when you first go into these environments. Like, it's all new services with all new events for all new APIs, and there's a million of them. So like, where do you even start? You know, so that it's real hard. Monitor that, and then automate remediation, and, you know, as much as possible, and still do things like vulnerability scanning. You know, again, these are process that you're already doing, but yeah. And then if you can remediate these stuff, you know, and what does automation of remediation mean? You know, if a new server is spun up and it really hasn't been approved, or it's an unimproved region, you can automate killing that thing immediately. If new users are created, you know, by, you know, an unimproved group, then those accounts can be disabled automatically, you know, things like that. So, and even account takeovers, if you have an account takeover, and that's detected, then you can have these high level you know, organization controls to just isolate that environment. And that's a big one. That's pretty, you know, that's a big decision, but again, the capability is there. And to go with that, you have something that was put out by IANS, called the cloud security maturity model, and it's all about automation for the most part, because again, cloud security, that's how you do it. That's how you do it well. And so this is something that you should be familiar with. Have an honest assessment of where you are at all times, and you know, at the beginning of your process, where you are currently, where you are in 6 months, where you are in a year, and make sure that you're improving. And these, this is your North Star. Make sure that you're driving towards automation and not just migration. Migration is not the end goal. And you don't have to be level 5, and these aren't exclusive. Sometimes you're somewhere in between level 2 and level 3, but it's a good guideline. And so where do you go from here? This was the basics. This is the getting started. This is the things that you could kind of just focus on. And organizations, you have a way to segment not just networks and not just applications, but entire organizations and accounts. Is you can deploy a development environment that's not even remotely attached to your production environment. You can deploy different parts of your business. You should have just a dedicated security organization where your logs go, that nobody can tamper with them, and you have non-repudiation. And we're almost out of time, so I'm going to just finish up. Cloud native security tools. Get familiar with what's in the cloud, built for the cloud, meant for the cloud. Asset management. Know what you have. Training. Invest in training early. Invest in training often. Make it a priority. And at OccamSec, at some point when you're ready, make sure that you're doing pen testing and assessment, that you're not missing things, and get that third-party perspective. And with that, I'd like to thank everybody for coming today, and I hope that was helpful. And if you have any questions, we're here to help. So you can reach us at LinkedIn, Twitter, or info@occamsec.com. And with that, I'll turn it back over to Spencer, and we can take any questions if there are any available.
Yeah, thanks, Jason. And just a reminder, folks, you're welcome to use either the chat box or the Q&A box if you've got anything. We did, at the end, you kind of touched on pen tests, and so I think one of the questions that we get typically is just at a very high level. Can you give us how does a pen test, do cloud systems need a pen test, and like what's the difference between a cloud versus an on-prem assessment?
Sure. Yeah, it's a good question. I guess to start off, you need everything that you would do anyways, right? You need application security pen testing. If you have an application that's in the cloud, you should you should do tests against that, and make sure that you're covering external infrastructure. I think one of the things that's specific to the cloud, and again, it goes back to identity and things like that, and really, it's not even just the cloud. Again, none of this stuff is really just the cloud, but it's still important. Is kind of that assume breach mentality. Is if somebody does gain access to credentials, if somebody does exploit an application, what can they then do within that environment? And I think that's an important one, is that a lot of people, think that it should just be a black box external test, and that if they pass that test, that, that things are good. And a lot, I guess the other thing to consider specifically to the cloud is security. So configuration audits, specifically, because misconfigurations are such a big deal, assessing that those controls are in place. And so I think those are kind of some of the unique parts to the cloud.
All right, thanks. And we actually had 2 questions about third-party vendors. I think the first one was, can you tell us, or I guess who says what tools are good or can be trusted when it comes to integrations with AWS?
Ooh, that's a loaded question.
It wasn't staged, I promise.
No, it's a difficult question, and it goes back to what we said. One of the problems with the cloud in general is in the migration is that there's a amazing marketing department behind every product, right? And so it's really hard to determine, to get past the fluff and to determine where the meat is. And oh gosh, reputation. Find out, reach out to the community. How, that's how I learn stuff. I'm part of, communities of people that are way, way smarter and more experienced than I am. And I listen to them a lot of times. So, get involved in the community outside of the companies and outside of the salespeople. What are people actually using, and kind of get some of that deeper insight in terms of, and every tool and every vendor has shortcomings, right? So find out what they're not good at, beyond what they're selling. So that's, I think that's one of the key ones. When it comes to cloud native companies, I think tend to know the environment a little bit better. And just like, you have companies that are founded prior to 2010 having more misconfigurations, I think it's also harder for security products that were built for a different environment to migrate into that environment. And so that's not a exclusive rule by any means, but I would just question it. It's something like, if it was built for something else, is it fully applicable to this new environment? Yeah. And then again, have your threat model in place. Again, follow your standard practices, have your threat model in place, and talk to the architects and engineers for that company, and have them identify how their product actually applies to your business. And your business shouldn't have to necessarily adapt to their product, and just to have that, and trust that that is going to be right. So yeah, it's again, it's still vendor management is always hard. There's so much snake oil and smoke screens, but do your research, talk to people.
Okay. And it actually that dovetails into the next one, which was, do you have any recommendations? And I think kind of specifically, it might be geared towards SolarWind, but do you have any recommendations to lower the risk of being affected by a third-party breach?
Yeah. That's a big one. I mean, with SolarWinds, people are, still trying to figure that out as far as what, 6 weeks ago or 8 weeks ago or whenever that was. Gosh, I'm trying to, I mean, the first thing that pops into mind is, again, it goes back to covering the bases, covering your basics, defense and depth. Don't just trust these things, and take your responsibility seriously. Even part of the SolarWinds breach, I mean, we're still getting new information about the extent of that, but you kind of have in the Senate going on is, blame trying to get put on companies like Microsoft for not mitigating these things when people don't have MFA controls in place. And things like that, is that yes, you're working with third-party infrastructure and vendors and stuff like that, but not to be harsh, but at the end of the day, that's not their fault. Everybody knows that you should be using MFA. That's not a new thing, so it's and check. I think, again, a large part of it goes back to training, is that you don't just have blind faith in other companies, and don't give them unrestricted access. And this is something we've seen even with like contractors, that contractors for a company that is not even part of your company have 20 people that have administrator access to your cloud. Stuff like that is so I guess, to not to be too ranty and stuff like that, but I think the best strategy is to again, is to threat model appropriately, have defensive measures, and monitoring. I think that's one of the big ones too, is people are still trying to figure out how to monitor things in the cloud. And when something happens, they don't know that it happened because it goes undetected. So I don't know if that's a direct answer or a good answer, but it's hard. I will say that it's hard. And the industry is moving quickly, where there's a lot of pressure to adopt things before you fully understand them.
Yeah, well, thank you. And that leads into the next one, by happenstance, promise not staged, is having a cloud service provider, like a third party managing your cloud environment a good idea?
If they're better at it than you are, then yes. But again, don't trust them, uh, don't give them, unbounded trust. I don't know the right way to say that, but, again, how do you approach it? Again, this is kind of high level, CISO kind of manager kind of stuff is identify where the risk of them managing is it, and try to have controls in place. And I think one of our strategies is, one of the best strategies is to work yourself out of a job when you're performing a service for another company. And so, have a roadmap in place. It's like, we need you right now because you're better at us than we are. But we want to work with you so that we can understand this environment better and start to have more agency over our environment over time. And if somebody doesn't want to do that for you, then that's kind of a red flag to me sometimes. And the reality is, honestly, if somebody really does that well, they've earned your business and you're not going to leave anyways. So, again, ask them questions, take your, do your threat modeling internally. Don't necessarily just trust them for it, and have those hard conversations of like, how are you addressing this? What controls do you have in place in this? What are you going to do, in the incident response process to work with us, that, in the event of an event, when an event occurs, things like that is, treat them to the extent possible as an internal division of your organization, and invest in the people in your organization. I cannot say that enough times, is train your own people, even if it's, somebody else's job today.
Okay. And I think the last one that came up kind of when we were talking about, talking about Capital One is, what advice do you have, or what should businesses do rather, if they've been breached, or if they think they've been breached, like in terms of configuration, I guess.
Yeah. I think it goes back a little bit to the previous point, is that, you should still have an incident response process. You should still have, kind of follow-ons for, after that process is, looking at your controls and remediation and ensuring that can't happen again. Again, if you're working with a vendor that manages that, ensure that they're involved in that process and clear and open with you. And yeah, and it's like anything else, it's got to be thorough. And the hard part with the cloud is that, it is hard to know that you can't go like just rebuild the server, right? Some of these tactics that are, in a physical world, where like the only way that you can be sure, that a machine is infected 100% is like just rebuild it. You can't do that in the cloud, right? It's not that environment. So yeah, good monitoring, good incident response. Learn from your mistakes and learn from other people's mistakes. If it happened to Capital One and you think that you might be vulnerable, make sure that that you have the controls in place, maybe that other organization didn't. So yeah.
Okay, awesome. Well, thanks, Jason. And those were the questions that we received. And just a big thanks to everyone who joined us today. Appreciate it, and I hope you'll have a good rest of your day. And if you have anything that comes up or you want to ask, you can always reach out, and we'll get back to you. So thanks everyone, and have a good afternoon.
Thank you. Aloha.